Okay, so last class, two days ago, yeah. So on Tuesday, we started reviewing chapter 5. 5.1 is all about rules of exponents, etc., etc. So that's why we're doing like 4 to 5 pages of simple just review, try to make sure we're all on the same page. Because if you don't know how to do this, I mean, it's going to be a harder chapter knowing how to combine exponents. So we want to simplify using the zero exponent and negative exponent properties. So all this means, okay, so all this means is the zero exponent property is anything to the 0 power is equal to 1. So if I put 1,296,763 to the 0 power, what does that equal to?
1.
1. Perfect. The only trick is like 0 to the 0, and I'm not going to ask you about it because that's more than the scope of this class. So anything to the 0 power is just 1. So if I have, how about like 5 times x to the 0, what is this? 5 times 1, which is 5. So I can just write this as 5. I don't have to include x to the 0 because that's just 1. Anything times 1 is itself. So if you have an exponent where it's 0, you can just leave it out. And then the negative exponent property. The negative exponent property is if I have something like x to the negative 2 power. This will be the same thing as 1 over x to the 2nd power. So to get rid of the negative of an exponent, you take the whole thing and put it on the other side of the fraction bar. You get rid of the negative by putting it on the other side of the fraction bar. So the way I can trick you, I'm going to try to tell you the trick plays. What if I have something like 1 over y to the negative 3 power? Yeah, I get rid of the negative in the exponent by putting it on the other side of the fraction. So I can put it as y to the 3rd over 1. Also, don't leave it this way. Don't write it as y to the 3rd over 1. Just leave it as y to the 3rd power. So when in doubt, simplify your fractions. Even when not in doubt, simplify your fractions. So on your finals, there was a lot of like negative 2 over 1. No, just write negative 2, okay? Yes? Yeah, if you come to bonus, you can like see it. Yeah. I have them all. It's a math policy. We don't like give them back for you to keep. But yeah, you can come to bonus, or you can email me and be like, oh, hey, can I see it during lunch or whatever. Yeah. Cool. Okay. So these are the 2 rules. Assume no denominator is equal to 0. And now that we have these 2 skills in our arsenal, we can go through and do these problems. So this first one should be a relatively nice review. X to the 3rd times y to the negative 5 times x to the negative 8. So when I have the same base being multiplied, I'm just going to go down the row. Jesse, what do I do when I have the same base being multiplied? I'm going to...
Isn't that a negative and a positive?
Yes, but I want to...
Make an addition?
Add. I'm going to add the exponents. Same base being multiplied, add the exponents.
Yeah, sorry.
It's fine. So plus negative 8. And then I only have 1 y, so I'm just going to write y to the negative 5th. 3 plus negative 8 is just x to the negative 5. But we don't want to leave them with negative exponents. Remember the 3 things to check for to make sure you are simplified. No parentheses, no repeated factors. So here, this was not simplified because there's 2 x's, right? And they're being multiplied. So we want to combine them. And no negative exponents. So instead, I'm going to write this as 1 over x to the 5th, y to the 5th. And that's the way I'll leave it. No negative exponents in your answer. What?
Wouldn't you move it? Because you said you have to move the negative to like the other side.
So to get rid of the negative, you write the whole thing on the other side of a fraction. It's the exact same thing. You just get rid of the negative, but put it on the bottom.
It always has to be in a fraction?
It will be on the other side of a fraction bar.
Okay.
Yeah. So up here, I tried to show you the trick. Like here, I wrote the exact same thing below the fraction bar, just get rid of the negative. I write the exact same thing above the fraction bar, get rid of the negative. Like this second part, the y one, this is the way I can like try to trick you and make sure you understand what to do. Like this is probably the hardest way I can ask you. What else am I gonna say? your quiz next week. It's 5 problems with 1 bonus. I made the long division a bonus problem. You're welcome. There you go. Synthetic is your 5th problem. There's 4 different problems on like 3 problems from 5.1, 1 problem that's monomial division, which we are about to cover. Cool. Just so you know about it. Caitlin, do you have a question? The test. If you look at your lesson plan, do you have your lesson plan? So look at the lesson plan. I have it all listed for you. Okay, let's try the next one. So how can I write this b part? I have 12 to the negative 2. So this is the same thing as Felix. How can I get rid of the negative in the exponent?
You put 1 over 12 squared.
Yeah, and what's 12 squared? 144. Perfect. Also, I'm gonna let you use your calculators for the quiz. I think I told you I wasn't, but I decided to. Because honestly, it's not really gonna help you. It will just be like to make sure you do computations correctly. I don't want you to miss a point because you forget how to multiply, you know? Yeah, because that's not what I'm testing you on. I'm testing you on rules of exponents. I don't want you to miss points for computation. All right. Solid. Let's try the next one. All right. Can I move scroll? Everyone's done. Okay. So let's go variable by variable. So first, let's take care of the numbers. So I have negative 15 over 5. I have w to the 0. There's no w on the bottom, so you could write like 0 minus 1. But I'm just going to leave it as w to the 0. Now I have a u. Ooh, I have a quotient bar. So Jordan, what do I do when I have a quotient bar? I have to do what to the exponents? Subtract. Yeah, trying to make, because I made a plus sign for him. Subtract. When you are multiplying the same bases, you add the exponents. When you have 2 bases, right, and they're being divided, you have to subtract the exponents.
Wait, so if you're adding the bases,
Not adding, multiplying the bases.
Multiplying the bases, then
you add the exponents like I did in A.
And then if you're dividing
you subtract the exponents. Then
you
subtract the exponents.
The base or the exponents?
You're adding the exponents when you're multiplying the same base together. If you're dividing by the same bases, you're going to subtract the exponents. Okay, so negative 15 over 5 is negative 3. Anything to the 0 power is 1. Okay, so I don't need to write it, right? Anything times 1 is itself. So that just goes to 1. And then u to the negative 1 minus 3 is negative 4. Negative 1 minus 3 goes to negative 4. But I can't leave it with a negative in the exponent. So I'll write negative 3 over u to the 4th. So all I do to get rid of the negative in the exponent is take u to the negative 4 and put it on the bottom and get rid of the negative. So
why didn't you do that for like b? Why didn't you make it negative 1 over 144?
What?
Because it's not simplified all the way.
When I have 1 over 12 squared, you have to simplify 12 squared.
No, I know that, but how come you moved the negative to the top on C but not B?
Move the negative to the top. C, not B. B, like 12 to the negative 2? Is that what you're looking at? 12 to the negative 2 power?
On C, you had the negative for 3 to the power of negative 4, and you moved the negative
3
up
to the power of
3.
negative 4. What do you mean 3 to the power of negative 4?
3
So,
to the power of negative 4.
yeah, so because I'm looking at u. There's a u on top and u on bottom. And to combine them, because they have the same base, you have to subtract the top exponent from the bottom. So I take negative 1 minus 3.
Oh, negative.
And then I get u to the negative 4. And then, oh, negative 4 is an exponent. I can't do that, so I have to put the u to the 4th on the bottom. Okay. So D, there. This is, D is for difficult. So what's the first thing you think I should do? Caitlin, what's the first thing I should do here? Close. Yeah, let's distribute this out. So this is a nice review. We have a power, right? We have powers to a power. So if I have a power to a power, what do I have to do to the exponents, right? So j to the negative 1, do I add, multiply, subtract, divide the negative 4, Cooper? Multiply. Because I have a power to a power.
Okay.
So multiply, and then I have k to the 3 times negative 4. Now I'm going to leave the bottom alone because I'm trying to do only one step at a time. Okay, so first j, equal, all right, negative 1 times negative 4 is 4. Negative 4 times 3 is negative 12, and this is all over j to the 3rd, k to the 3rd. So this was 2 steps. We used the fact that we had a power to a power, right? An exponent to an exponent. We have to multiply the exponents together. And now I just have a pure quotient. So let's come back around. Jackson, what do I have to do when I'm, if I want to simplify more, what do I have to do now?
You have to add the 12k to the 3k.
Close. Subtract. Gotta subtract
No, you
them.
have to bring them down though. Or do you
I'm just
subtract
gonna use the rules of exponents for quotient. So since this is a quotient, I'll take the top exponent, subtract the bottom. The top exponent, subtract the bottom. So I have j times k to the negative 15. And then once I end with a negative exponent, gotta simplify that by moving it on the other side of the fraction bar. Is equal to j over k to the 15. Perfect. So, what did you do?
Instead of subtracting the 12k, I just bring the 12k down and just.
Oh, and multiplied them then. Yeah.
No, the negative 12k, just bring it down and just added the 3.
So multiply. So you brought the 12k down by putting it on the other side of the fraction. And then since you're multiplying the same base together, you add these together and leave it on the bottom. Yeah, it's the same thing. Yep. Perfect. Cool. So instead of leaving it as 12, k to the negative 12 on top, he moved it. So on the bottom, he would have, let's see, j to the 4 times j cubed times k cubed times k 12. And now that they're on the same level being multiplied, that turns into k to the 15th, but notice it's on the bottom of the fraction. Awesome. So we have the same answer. Do you have questions over this one before we keep going? Okay, because we'll have more practice with this. Simplify each fraction, simplify each expression by combining like terms. This is a big common mistake that we keep making. Notice that I put parentheses around these, and there's a negative in front, so I need to distribute the negative out. Otherwise, you won't get the right answer. You'll end up forgetting that you're actually subtracting, and you'll be like, oh, 4 minus 5 is negative 1. No, you need to distribute the negative first. If it was just an addition, you would be fine. You could just straight across combine like terms. But notice that the sign in front of these change once you distribute the negative. Now that we distribute it out, we can combine like terms. So try to combine these like terms. So try to do it on your paper. So unless you've done it already, you should be working on it. I want you to combine these like terms. Okay, and when you're done, double check that you got the answer I got. Because when you have negative x squared minus x squared, that's negative 1 minus a negative 1, which is negative 2. So I have negative 2x squared. Oops. So you only can combine like terms. So what that means is, notice the x squares you only can combine with other x squares. The x's you only can combine with x squares. It has to be the exact same variable with the exact same exponents. So that being said, we're going to try the next one. And this is just positive. So cool, we can just combine across. There's only one x squared term. There's only one x term. And if you take negative 6 plus 1, that's just me negative 5. There's no other way I can simplify. Because remember, simplifying, no negative exponents, no more parentheses, all like terms combined. That's what we want. any fractions, simplify to lowest, so there's no common factors. Perfect. Couple more seconds to write down. Okay, now we're going to simplify using the distributive property. So what we have to do is multiply 4/3 x squared to each of these terms. So you multiply the coefficients together, and then notice I have an x squared and an x squared. Since I'm multiplying the same base, right? Both bases are x. What we're going to do, multiplying the same base, we're going to add the exponents. So 2 plus 2. Next, I have 4/3. I'll be multiplying by 9. I have an x squared and an x being multiplied. It's the same base variable of x. So since they're being multiplied, you have to add the exponents, 2 plus 1. And then I take 4/3 times 12, and there's no other x, so I just leave it as x squared.
Now, why are you distributing the whole thing to each thing?
Because it's outside the parentheses. And it is, each of those terms has to be multiplied by it.
Okay.
Yep.
I thought each arrow was pointing to like one was to the 4, one was to the 3.
Oh, no, I'm just trying to show how to go to each term. Every term has to be multiplied by 4/3 x squared. Okay, so the reason I left this fraction in here is it's actually, it's harder than it looks. So if I want to simplify, what is 6 divided by 3? 6 divided by 3? 2. 9 divided by 3? 12 divided by 3? 4. Oh, okay, so that's fine. I can simplify that way. Or you could have said 24, right? 4 times 6 is 24. Divide by 3 is 8. 4 times 2, 8. I get the same answer. X to the 4th plus 4 times 3 is 12. X to the 3rd minus 4 times 4 is 16. X squared. I think the hardest part here is like making sure you distribute to every single term. Realizing you have to add the exponents when you are multiplying the same base. Yes? Oh no, you're throwing it. Do it. If you played basketball, I would have made a joke, but it's fine. Okay. Okay, to move the notes over. Nope, okay. So you could flip it, but I'm actually just going to distribute and figure out the figure out the exponents, and then at the end I'll flip it. I'm trying to make it as easy for myself as possible, so I deal with negative exponents at the end. So here you are distributing to every single term. So I'll give you, I don't know, 20 seconds. I want you to try out this problem. I'll write out the answer on the board, but I want you to give it a shot yourself first. So when I look up, I should see everybody working on their paper. So on grades, there is work behavior, and there's work habits and behavior in class. So I'm going to try to do a better job of tracking that this semester. So if you don't follow along and take notes in class and do the problems, I'm going to write that down so I have an accurate representation. Cool. I'm just trying to force you to do the work, so that way you understand it better, and when you go home, you can actually do it by yourself. Cool. Okay. Another 5 seconds or so. Okay, so after I multiply the coefficients together, add the exponents, I see a couple things happening, right? This a to the 0 power, well, a to the 0, this is just equal to 1, so I don't need to write it. I also see, oh, a to the first power, normally if we have something to an exponent of 1, we normally don't write the exponent. It's assumed to be there. If I just see a with no exponent, it's assumed to be 1, yeah?
So, do I have to write like the thing that you wrote in red, like on like the quiz or test or whatever? Cause I kind of just did that with the
So if you do the green line and then the black line,
yeah.
that would be fine. So these are like notes I upload, so I try to make sure that it's very clear. Because you guys, I mean, if you have a question looking through your notes and you don't write everything, you're like, I have no clue how I got this. Like, you might reference my notes, so I try to be as clear as possible. If you just have these two lines, that's fine. The issue is if you only write this line and you accidentally, like, do the math wrong, right? It's very real. Maybe you forgot, like, oh, maybe you made this negative, or you multiplied the exponents or something, right? The more work you show, like, more partial credit I can give. If you don't show anything, there's no way I can, like, help you if you do it wrong. So if you just show, like, you know, intermediate steps. You don't necessarily have to show, like, oh, adding. You can just show the green line. That's fine. Okay. Let's go on. Find each product. So you should be able to do A, right? We've done it before. In order to find the product, we must FOIL. One more time. Ooh, we have two binomials multiplying. How do we solve it? We must. Oh, you just said the answer. Ready? 1, 2, 3.
FOIL.
FOIL. FOIL. First, outer, inner, last. You must FOIL. Yes.
I have a question about the last one. Why isn't A over or everything else over A?
Because I dealt with the A's individually. The first term had an A to the first power. The second term, the A went to A to the 0, and the last term was A to the negative 1.
Okay.
Yeah. All right, FOIL this guy out. First, 3x times 2x is 6x squared. Oh, outer, negative 4 and 5, oh, sorry. Outer, negative 3x plus 5 is 15x. Inner, negative 8x, and last, negative 20. So I end up with 6x squared plus 7x minus 20. So, confident you guys could do this. This should be like the confidence booster question, right? You knocked that out of the park, you're solid. So, now that we reviewed how to FOIL, let's take it one step further. Look at part B. We have 3 binomials. Ay, ay, ay. Do you know how to eat an elephant? What's the best way to eat an elephant?
Cut it in half.
There's a saying. Do you not know the saying?
I've never heard it.
How do you eat an elephant? 1 bite at a time? Okay, what that means is you break it down into smaller bits.
I don't get it.
You know how big an elephant is?
So big.
Yeah.
Yeah, so how do you, 1 bite at a time. You break it down and do one small thing at a time.
Or you just
Don't
don't
you
do it
eat
at all.
everything?
Okay, you're missing the point, right? This is the point, that's where you are. You're totally missing it, it's gone.
Don't eat elephants. That's much bigger.
It is. Missing the point. What I'm trying to show you is, I did this lesson with my other class. So seeing how they reacted, how my kids reacted last semester or last year, trying to prepare you, trying to show you. Because I don't want you to look at this and be like, I have no clue how to do it, I'm done, goodbye. No. One thing at a time. There's 3 different binomials you have to multiply. Best way to eat an elephant, 1 bite at a time, right? Break things down into the basics. You have a hard problem, don't get overwhelmed, just break it down. How do you multiply this? 1 bite at a time. You multiply these first by FOILing, and then you take the answer and then multiply by x plus 3. That's the whole reason I made this metaphor. Okay.
So you just multiply.
So let's FOIL the first one out. X squared minus 4x minus 2x plus 8. So I end up with x squared minus 6x plus 8. So I'll pause here for a moment. Don't forget about the x plus 3. Right? I was multiplying these 2 factors together first, so then I can come back and multiply by x plus 3. So this is a multi-step problem. You have to do it just one thing at a time. That's the gist. I'm also trying to help you build resiliency, because you may not use this math later, but the fact that you don't give up when you see a hard problem, you will use that every day in your adult life. There you go. It is. So.
I know, but I like the way you just admitted that we're never going to use this in our life.
I'll freely admit that. And I'm very honest with you
A lot of
guys.
teachers,
I'm honest when I tell you the math that you really
they're
use.
like, yeah, what do you mean? Of course you use this.
Last year after
No, you probably won't use this. I don't know. If you go, it depends. Are you gonna take calculus? Okay, you'll use it.
You're gonna build a roller
Yeah, I could never forget that because I was like, I'm not
Okay.
building any roller coasters.
Bro,
I'm
what?
just trying to make a point, okay? I feel like I'm very honest with you guys,
Do
whatever.
you foil that as well?
Yes, well, kind of. It's not necessarily foil, because, everyone hear Jesse's question? Don't sit up. Okay, Jesse's question is, do we foil it? Close. Foil is a four-step when you have two binomials. What do we call this left one right here? Trinomial. Yes. High five. Okay, it's a trinomial, so it has more than four parts. Okay, but don't despair. What we do is we take this x, multiply it to every term, and then we have to take the 3 and multiply to every single term. And then once we write those out, we combine like terms. How do you, oh my god, how do you know elephant one by a time, right? It's a lot of work, but if you just do it little step by little step, you will finish it. It's,
I love math.
Okay, yeah, that's
you know, like, honestly, my goal is you just not to hate it. I just be neutral about it, okay? It is what it is.
I love it.
I'm glad. Let's do this.
You do the same problem, so once you do the x,
You multiply the 3 by all of them.
yeah.
Yep. So, I'm going to color code so you can see. Shh. Come on.
Does it matter if you
Come on,
multiply
come on,
the x
please.
first? or
Don't make me
the
mark you
three
down
first?
for being distracting. Come on. So, we are going through taking the x, multiplying by all the terms in the trinomial. Then I take the 3 and multiply it to every term in the trinomial. I'm going to write it out in color code. That way you see what's going on.
It does make a difference if you do the other order, right?
What?
Like if you did the 3 first.
No. Because you combine like terms at the end.
Commutative property.
Please focus. Sit up. Sit up. Write on your paper. Let's go.
I have it all here.
Okay. I just, I love your voice and I like your opinion. I just want to do the problem.
Then x times x times x cubed. No, x.
No, that would be 2x. So wait,
Right, so then it would be 2x.
Yep.
you foiled. No, x. You foiled the first thing and then you foil it again and then multiply it by x times x plus 3.
Yeah, so I had to multiply all of them by x's on multiply them both. Because there's 3 terms. So I have to do the first 2 terms first, then the other one. Okay, we must combine like terms. There's only one x to the 3rd power.
Oh yeah, it is.
Okay. Ooh, look, there's only
x minus 18x
one-
plus 10x on the tele.
Oh, I forgot one. Sorry, hold on. This is supposed to be squared. So notice I have, I'll wait a sec. Okay. So we have 2 squared terms, so I must combine them. Negative 6x plus 3 is negative 3x squared. I look for my terms with just x. So plus 8x minus 18x is negative 10x. And then lastly, I have the constant term, which is plus 24. Not horrible, very doable. Just multiple steps. There's like so many things you have to do. But it's not as bad as long division. And I'll tell you, I hate long division. I hate long division. And that's why it is the bonus question on your quiz, and synthetic's the one that I care about and what matters. And that's why that's the real
We
question.
get our calculators on the test.
The quiz? If only I said that in class. I know you weren't listening. That's the issue.
Which is the one?
I did. Yeah, you were. I literally said it in this class period 20 minutes ago. You can have your calculator for the quiz. Surprise! You can have a calculator for the quiz. Okay.
Okay, so sometimes chapters, they kind of stay on the same wavelength, and then sometimes they start somewhere and they literally end up in, a whole different, is that what this chapter does? Yeah. Is that why it's so?
That's like chapter 4 and I failed that.
It's okay. I'm working on making this better. Okay.
Okay, I already submitted the application. So I'm getting someone who actually helped me.
Mr. Brian.
All right. Let's keep going. Shh. You guys, I need to finish this lesson so we can go on to long division. Please focus. Please focus. Question?
Can I use your biology class?
I don't know. You're gonna say that. Go ahead. I swear that's what it was gonna be. Okay.
I'm very proud of myself for not
Alright.
using all three in like the first
Wait.
2 days.
Fair enough.
Don't
I
have
feel
math
like
off
That's good because last semester you used it the first 3 days.
Unlimited. You said
don't
we
have
could use
unlimited.
the
It's not unlimited. Okay.
What I'm feeling
So what?
You said that we could use the calculator on the test, even for the bonus question too.
Why are we still on this?
It's on the same page, man. What am I gonna do? Walk over and watch you and see when you go to bonus and take it?
She's
Yeah.
gonna do it for work.
No.
Oh, we
Okay.
have to buy on the calculator.
Except it doesn't do this because if you put this in your calculator, it's gonna pop up an error because you don't have x and y defined as numbers. Your calculator won't do it. And I put you in press test mode and it doesn't allow CAS, so it's all fine. Okay, the calculator is so you don't mess up multiplying 4 times 6. It's so you don't mess up when you take -6 plus 3. That's why. I don't want you to miss 3rd to 5th grade math. Okay? That's literally what it is. I don't want you to miss that easy multiplication addition. Don't lose points for that. Just don't lose points at all. All right. Question, yes. Is it irrelevant?
Yeah, is it irrelevant?
Is it relevant? Why?
Yes.
What's your question?
Do you distribute both things on like each side of the addition side of the add when you're done?
Good. Like this? What I just did in color?
Yeah.
Yes. That's what we're doing. So now we have. Now we're going to distribute 5xy times 2x minus y. Okay, so I have 5 times 2 times x. Well, I have x to the first power and x to the first power, so that's going to turn out to be an x squared. And then I have y minus 5 times x times y is the 1 plus 1. I'm going to use the other color for the other half of this, 6y squared times x squared, because there's no x that we're distributing, and there's no y in that one term. Plus 6 times 6y squared. Simplify it out a little bit. 10. Squared y, what?
How do you? Is it just after you're writing this line?
This is 2 lines. This is 2 lines of work. That's not a lot of work in my opinion.
No, I mean like there's a lot of things that could go
Wait,
wrong.
I didn't.
Making this work. That's why it's so
But if
like.
you
When I
show
did
your-
it-
Hold on. If we have questions, raise your hand, because I would like to keep going. Yes.
I didn't do that.
Do what?
Like I didn't do the line before that.
You went straight to this?
Yeah.
Same.
That, I
But
mean,
just because I just did.
okay.
It wasn't like I was like. You know
Okay.
What I mean?
But if you accidentally put like 7 right here instead of 10, or if you forget to write the square, I mean, there's no work to justify it, you know?
Okay.
So if you show work,
Just show.
I can give you more points. Yep. So that's the way it should be. All right. So question: are there any like terms to combine? So without talking, think in your brain. Without talking out loud. No voices. No voices. Is there anything I can combine? Are there any like terms? Any like terms? You have a question?
I do have a question because I don't know. For this 6y squared x squared, can you switch that to 6x squared y squared?
Yes.
Okay.
This is the same thing as saying 6x squared y squared. This is the same thing as saying 6y squared x squared. The order, because they're all being multiplied. Commutative property of multiplication. 2 times 1, same thing as 1 times 2.
So then there are like terms.
Where? Which ones?
10x squared y.
Ah, because this is not y squared. It's only y.
Oh, it's not?
No. Because you have 5xy times 2x. That's the question I was trying to get to. So, when you combine like terms, they have to have the same exponents and the same exact variables. So, if I had 10x squared y squared plus 6x squared y, or y squared x squared,
It worked.
yeah, that would be fine. That'd be perfectly fine.
I'm scared.
This would be perfectly fine. But because you have to have the exact same exponents. Notice these are both square, and that's fine. But in the actual problem, it wasn't. Okay, so that was it for 5.1. Let's go through 5.2. That took way too long. Okay. 154. So 25. That took half of class.
That's okay.
No, it's not. Okay. 5.2. Dividing polynomials, part 1, long division. This is the first day of 5.2. Felix, you have a question? Okay. Go take a walk. Go take a walk, okay? And then come back. Walk to like the water fountain back, okay? Clear your head. So,
Sorry, I just came on my god.
It's fine. Okay, so dividing polynomials part 1, long division. So let's take a break for a sec. So dividing by a monomial. Think back, monomial means one number. Monomial, one number. So you're dividing by a single term. So whenever, it's only when you're dividing by a single term like this, can you rewrite it? You can like break it up and rewrite it so each term is under 4c df. This is the only time you can rewrite it this way. Minus 16 c df squared over 4 c df plus 4 c df over 4 c df. So what I did was I broke the fraction term by term. The only time you can do this is when you have a monomial, a single term you're dividing by. If you're dividing by something like x plus 1, that's a binomial. You can't break it down term by term. Only monomials. Okay. No points. No, this is monomial division. There's a question just like it. Long division. Actual long division.
Like with real numbers.
Like the next example we're going to do. Like, no. Well, I mean, that is long division, but polynomial long division.
When are the seniors taking this?
What?
When are the seniors taking
It's 3 months. Beginning of April. 2nd to 4th.
this?
Yeah, so that's 3 months. So we got to get through it. 4, 5, 6.
Is that a CDF?
Yep. Felix. Like excited, college, finals, whatever, second semester, but we got focus, okay? We got focus. Because, not to be negative for a moment, but if you're a senior, you have to pass this class to graduate. You must. They will hold your diploma if you do not pass this class. Yes. Yeah. Let that be the focus and motivation. 59.5%. You must get a D minus to pull it through. And keep in mind, so like I'm keeping track of talking and bathroom passes. There's already a couple people who have lost half their points today. Come on. Waiting for people to focus. So let's go through and we're going to take each term by term. I need to simplify this one. So if you go straight and writing like 5, c to the third, d, like that would be fine.
So this is the
You
subtraction.
could cross this out and make it 1. Yes, it's subtraction. So I'm gonna show work a little better.
Is that what the
5 c to the 3, no.
different completely?
Yes, this is monomial, dividing by a monomial. We haven't hit long division yet. So this last one just turns into a 1. So this green part is not really necessary, but I mean the more work you showed, the better. Because if you make a mistake, there's not much I can do for you to give you partial credit.
Wait, we do need the 1?
What? If you go straight to this,
sorry.
that's fine. This is a simple enough problem. So what I would be expecting to see if this was your problem is at least this line where you break it and this line. If you go straight to this, I'm not going to give you points. I want to see you breaking it up. Yeah.
So you're only able to do that because the denominator is monomial?
Yes, exactly. We only can do this because we have a monomial in the bottom. If it was anything with a plus or minus, that would be not a monomial. What?
Is that a 1 times 1 with the e?
No, 1 minus 1. Because the top has an exponent 1, the bottom has an exponent 1. If I'm dividing by something like 4c plus df, notice there's a plus sign. That makes it a binomial. Monomials have no plus or minus signs inside them. They might be negative in front, but there's no like actually plus or minus signs in between them. That's how you can tell. So you only can do that if it's a monomial. All right, dividing a polynomial with more than one term. So if you have a polynomial and you're dividing by another polynomial, like a binomial is really all I'm going to give you. You're welcome. Algebra 2 does quadratics, which is like the squared. We only do single. This is today. This is tomorrow. So there's 4 steps when you are dividing polynomials. And I should have wrote this. So first, you have to divide. Then you multiply. Distribute. This is the order we're going to go through every single time. Then you must combine and draw the line. Draw a line, change sign, then you combine. Okay, these are the 4 steps for long division. So before we do polynomials, we're going to review with a general long division problem. If I take 123 and divide by 7, think about how you learned to do it, right? So first you covered up the 2 and 3. How many times can 7 go into 1? None. So you move over and say how many times can it go into 12? Once. You write the 1,
Bring down the 2.
multiply by 7, right? So you have to multiply by 7, and then you write it, draw the line, change the sign, and then you have to combine. 12 minus 7? 5. Bring down the 3. How many times can 7 go into 3?
7.
I'm sorry, 7 go into 53? 7. Okay, so we divided 53 by 7. Now we'll multiply. 7 times 7 is 49. Then draw the line, change the sign, right? It was a positive 49. Now I make it negative. Combine them, and I have 4. So you could write R4, that stands for remainder, or you could write 17 and 4/7. Okay, so you know these 4 steps we just went through? We're going to do the exact same thing, but with polynomials. So it's just, you know, a little harder. Okay, awesome. So I have x minus 3, and I'm dividing x squared plus 7x minus 30. So the first thing I must do is divide. How many times can x go into x squared? What is x squared divided by x?
X.
X. So I write the x above right here. First step, divide. Second step, multiply and distribute. So I'm going to take x and multiply it by x minus 3. I know, there's going to be a lot of like, what? But just like bear with me. Because x squared, so x times what is equal to x squared? X, yeah. And now I'm going to distribute the x to what I'm dividing by, x minus 3. So I have x squared minus 3x. Draw the line. And then we have to change the sign. So notice, oh, x squared turns negative, and the 3x turns positive. Because really we're subtracting it. We're subtracting a negative, which makes a positive. So x squared minus x squared goes away. That's the idea. We want the first term to disappear every time. That's the goal. 7x plus 3x is 10x. Bring the 30 down. Okay, and then we go through the whole cycle again. Now, we first divide. 10x, divide by x. 10, okay. Then, second step, multiply, right? Distribute 10. So I'm taking the 10 here and multiply it by 10x plus 3, because I was asking myself, x times what is 10x? Oh, 10. Okay, so I multiply it out by 10. 10 times x minus 3 is going to be 10x minus 30. Step 3, draw the line, change the sign. Then we have to combine. Hey. It's like a what do you call it? Poetry slam or a rap song. It's kind of like catchy. That's why I made it that way. Draw the line, change the sign. Oh my gosh, we have no remainder. It goes evenly? That's crazy. That means it was a factor of my polynomial.
So where do you get the like? I was a bit confused where you got the 10 from.
I'm so confused where you got everything, bro.
Do I look like a broke?
Okay, so up here, we had 12, and we said how many times can 7 go into 12? Oh, once, right? So I'm answering your question. Kidding me. Okay. So I had 12, and I want to know how many times can 7 go into it. So I said, oh, 1. So I wrote the 1, and then I had to multiply 1 times 7 here, subtract, and then I had a remainder, and I bring this next one down. Right?
No, I get that.
Okay.
But how did you get like the x plus 10?
Okay, so first I started with what times x squared? I'm sorry, what times x is x squared? X. Okay, so I take the x and I multiply it by x minus 3. X times x minus 3 is x squared minus 3x.
Oh my god, 7x plus 3x.
So I look at the x, to try to eliminate the coefficient, the first term. So here I'm looking for x times what number is going to be 10x? 10, right? So then if I take 10 and multiply it by x minus 3, I get 10x minus 30. Yeah. Okay. Let's try the next one. I mean, it's been a while since you guys did it. I think it was Algebra 1B, or the second half of Algebra 1 when you did this. So we're going to try the next one. Am I good to move over? Okay. So this one looks a little funny because we're actually multiplying, right? What the heck? Multiplying. But this exponent, oh, it's the -1. So this actually is dividing. X squared minus 13x plus 12 over x minus 1. So secretly we are dividing. So we're going to use long division. X squared minus 13x plus 12. So the first step, what we do is divide. So I want to know x times what is equal to x squared. Right, so I always take the first, the leading term, and divide by my leading term of the divisor, the thing I'm dividing by. Okay, so I'm trying to color code so you can see it. So if I take x squared divide by x, I get x. So I notice I put them in order. All of my x squares are in this column, x's, numbers. If you're very organized about it, you won't lose track of where you are. The more straight and organized you are, the easier it will be for you not to mess up. Okay, first step, divide. Check. I found what my missing factor is. Now I have to distribute, aka multiply x by the thing I'm dividing by, x minus 1. So I get x squared minus x. Third step, draw the line and change the sign of each of these, because we have a plus x, because when you subtract a negative, it's the same as adding a positive. Okay, the x squared goes away. Check, that was our goal. Remember, we're trying to get rid of the first term. Negative 13x plus x is negative 12x. Bring down the next term. Okay, now I want to know what multiplied by x is negative 12x. All right, so negative 12x over x is negative 12. So if I distribute negative 12, multiply it by what I'm dividing by, which is x minus 1, I'll have negative 12x plus 12. Draw the line and change the sign of each of these. Once again, I get no remainder. It goes evenly. So if you multiply x minus 1 times x minus 12, if you FOIL those out, you'll get what we started with, right? If it goes evenly, it's one of the factors. If it doesn't, we get a remainder, it's not one of the factors. So for example, if instead of 0, let's say this was 5 as a remainder, okay? What we would then say is plus 5 over x minus 1. That's the way we would write it. You write your remainder over what you're dividing by. For you guys, I'll allow you to write it this way as well. You could write it as x minus 12 remainder 5, or you can say x minus 12 plus 5 over x minus 1. I will accept it both ways for you. For long division. For synthetic, I'll make you do it the bottom way. Okay, do we have questions over this one? Maybe? No? It's just a process. Just gotta go through the process. And I want you to feel the agonizing pain of how long it takes for long division. That way tomorrow you'll appreciate synthetic so much more. Synthetic takes 2 lines of work. Yeah, that's it. And it gives you the same answers. It is magic. Okay, so let's do another example. First, I want to make a note. So notice that in A we had x squared, x to the first term, and then we had an x to the 0, right, a constant term. What if I had something like x to the 5th plus x to the 3rd plus 5x squared minus 1, and I'm trying to divide it by, I don't know, x plus 2. If when I set it up, you have to include a placeholder for any missing exponents. So notice we don't have an x to the 4th term. We don't have an x to the 4th term. So when we use long division, you have to put a 0 there. So you must include placeholders for any missing exponent. So if I would set this up, right, x plus 2, I have x to the 5th, and I have to put 0 x to the 4th plus x to the 3rd plus 5x squared minus 1. You have to include the 0 here because I'm missing the x to the 4th term. Jordan, you have a question?
No?
Okay. Just expecting you to face it forward. Okay. So anytime you're missing an exponent, you must include a placeholder. Yeah. Okay, let's go on. Let's do another example. So 1 and 2, these are good if you want to practice with monomial division. Number 3 is about the level of what I'll put on the quiz. I would like to do number 4. Actually, let's do number 6.
Is extra credit or is that?
What?
Is that
No, this is more practice. What I'm telling you,
Is going to be on the test is extra credit or I mean on the quiz?
long division is the extra credit question on your quiz. Long division is like the one I'm about to do, which is number 6. Like
But 3 we have to know how to do.
3 is monomial, of course, it's on the quiz because it's only one term. 3 is the level of the monomial question on the quiz. But 4, 5, 6, 7, these are all long division. I would like to do number 6 because it's harder, because we do have to include missing. Waiting till everyone's facing the board. So number 6 is hard because where's the p squared term? P the first term. There's none. So we have to include the placeholder. Right? So if I'm taking p1 and I'm dividing this, you have to include the placeholder plus 0 p squared plus 0 p to the first minus 6.
So it has to be like a ladder.
Yes, it has to be exactly like a ladder. You look at, that's a great analogy. That was great. Yeah.
I'm so good.
You have to include placeholders. You start with your highest exponent, and then you have to have a place for every single exponent under it. So we started with p third. We didn't have a squared term, so technically the coefficient's 0 because it's not there. 0 times anything is 0.
Why don't we do this for the other one?
Because we weren't missing any exponents, right? We had squared to the first power and then a constant. Squared to the first power, constant. It went in order. And this is why I skipped to number 6, because look, number 4, squared to the first power, none. Squared to the first power, none. Oh, here we finally have one missing. Number 7, there's no t to the first term, so you'd have to put a 0 there.
But if it was x to or p to the second, and
If this was p to the second minus 6, you only would have to have this one, 0 p to the first.
yeah.
You have to have a placeholder for all the exponents you're missing after the biggest one. 9, 8, 7, 6, 5, yeah. Yep. Okay, so first step, divide. P cubed divided by p is just p squared. This is exactly why we have to have placeholders, because when I go through and distribute p squared times p minus 1, I have p cubed minus p squared. I end up with a p squared, so I need a column for it so I can be organized about this. Similar, like in synthetic, which is the next thing, you also must have placeholders for any missing exponents. Unfortunately, it's just something you have to do. No, nothing you can do about it. P squared divided by P is P. Distribute it out. P squared minus P. Draw the line, change the sign. So I have P minus 6. Oops, I meant to put this in black.
Wait, when you do P squared divided by P,
It's just P.
What's that extra thing on the bottom?
This is distributing. This is the next step. Remember I went over the steps up here? How do you do long division? First divide. So I divide, and then that's me showing the multiplying, distributing. Then I like write it out underneath.
Then you do what?
So, okay, you see this problem right here? Like, this is the portion that I'm looking at because it's the highlighting.
Oh, I see.
This is the
And
portion where I'm like
that's
trying to show some work.
3. Okay, I see.
Yeah, it goes like that way. So that's also I'm color coding so you can see what I'm doing step by step. Okay, so I have P minus 6. I need to divide. Oh, that's just 1. So I come up here, plus 1, distribute it out. Change the, draw the line, change the sign, and I end up with -5. So I have a remainder. Not only did I need to have placeholders, we finally have a problem where we have a remainder. This does not go evenly. So in order to write this, I would say minus 5 over P minus 1. So the answer, I'm just going to write it so I can box it. P squared plus P plus 1 minus 5 over P minus 1. So this was a hard one. You could do it. It's just better to be in this habit. Because if you go to trigonometric algebra next year, if you take like algebra in college, like your next class is going to make you do it this way. But I'm trying to be a little nicer since this is hard anyway. So you should try to do it like this, but like no, like this bottom part, this is your remainder. Okay. Do you want to try another one? Let's go up and do another monomial problem as an example. This should be a little nicer. Let's do 3 because it's similar to the one that's on the quiz.
So this we could split up into the...
Yeah, because it's a monomial. Notice that it's not 12a plus b squared. It's all being one term. So you can take it and rewrite it as 60a squared b cubed over 12ab squared minus 48b to the 4th over 12ab squared plus 84a to the 5th b squared over 12ab squared. So this is, same difficulty you'll have on your quiz. 3 terms with a monomial, 3 terms. And then if you wanted, you could go term by term, like show it that way. 60 divided by 12, 5. A squared over a is just a. And then b cubed over b squared is just b, right? Because you have a to the 2 minus 1, b to the 3 minus 2. Minus 48 over 12 is 4. B squared over a. Because 2 of the b's cancel out and there is no a on top to help us out. 84 over 12 is 7. A to the 5 minus 1, b to the 2 minus 2. Well, b to the 2 minus 2 is b to the 0, so that's just equal to 1. So I end up with 7a to the 4th power. Cool. All right, so when you're going through your homework, make sure you practice the 4 steps of long division. So knowing that this takes you a while, I think I tried to make it not horribly long. 9, 10, 11, 12. 12 problems, and 3 of them are SAT prep, so it's not too bad. See you guys tomorrow.